The following module discusses the standardized mortality ratio, short form SMR, which refers to an indirect method of standardizing mortality rates of populations. This SMR is a quantity which is usually expressed in terms of a ratio or a percentage that tells us the increased or the decrease in mortality of a particular study population with respect to the general or what is known as the standard population. In other words, the measure tells us how many persons per thousand of the population will die in a given year and what the causes of death will be. Therefore, when there is an SMR greater than 100, we can say that the population under study has excess mortality relative to the standard. The SMR is often used in life insurance companies in order to periodically update their premiums based on mortality rates, and medical researchers also use it in order to track diseases related deaths, using these statistics to shift attention and funding towards particular risks. The limitations of the SMR is that a lot of caution would have to be used if few deaths would affect how the SMR is to be interpreted in a particular study population. But suitable statistical techniques can be used. The SMR also cannot easily be compared across areas as the population profiles may differ and therefore have different weights assigned in the method of calculation of SMR, making comparisons difficult. Fetal mortality, also covered in the following module, is a term used to cover all stillbirths, miscarriages and abortions, but a more strict definition does not cover the very early stages of pregnancy. Further discussion can be found in the module.
I am Dr. C.P. Prakasham, retired professor from International Institute for Population Sciences, Mumbai. Module 36-37. This module combined two topics: Standardized Mortality Index, Fetal Mortality. In this module, we will learn about definition of Standardized Mortality Index, ratio, SRM, uses of SRM, examples, fetal mortality data. In epidemiology, the standardized mortality ratio SMR is a quantity expressed as either a ratio or percentage quantifying the increase or decrease in mortality of a study cohort with respect to the general population. Award and Scodal 210. Standardized mortality rate tells how many persons per thousand of the population will die in a given year and what is the cause of death will be. Such statistics have many uses. Number 1. Life insurance companies periodically update their premium based on the mortality rate adjusted for age. Number 2. Medical researchers can track disease related deaths and shift focus and funding to address increasing or decreasing risks. Number 3. Organizations, both non and for profit, can utilize such statistics to justify their mission. Number 4. Regarding occupational uses. Standardized Mortality Index SMR. This is the ratio of the number of observed deaths in a study group to the number of that would be expected if the study group had the same specified rate as in a standard group. This procedure is the same as indirect method of standardization. The ratio is sometimes multiplied by 100 to express it in terms of percentages. SMR equals to observed number of deaths divided by expected number of deaths multiplied by 100. The denominator is SMR is based on the specific rates in the chosen standard population. These are not necessarily age specific but be gender specific, exposure specific or specific for any other categorization. An SMR greater than 100 is interpreted as indicating that the study group has excess mortality relative to standard. Table 1. Calculation of SMR in textile workers age group years. Here the following table describes how to calculate expected deaths. Age group in years it is given 25 to 34, 35 to 49, 45 to 54, 54 to 64. Age specific death rate in the national population per 1000 observed deaths are given as 10 per 1000. Below is given the age specific death rate. Textile workers are the subjects here. Number is given in the column 3 and expected number of deaths is calculated, that column number 3 multiplied by column number 2 will give you the expected number of deaths, and total expected number of deaths is calculated as 6.8. The steady and the standard group can be disease and control groups in a case control study or general population of two types or any other group of interest. In this method, more stable rates of the large populations are applied to the smaller steady group to obtain the expected number of deaths. SMR gives a measure of the likely excess or reduction in mortality in the steady group. SRM example, age specific death rate is equals to age specific death rate observed number of deaths 10 per 1000 population. Then SMR equals to 10 by 6.8 multiplied by 100 is 147. This shows that the mortality level of textile workers in this mill was 147% of the national average. This is 47% higher than that experienced by the national population. Another topic is fetal mortality. Fetal mortality is a term used to cover all stillbirths, miscarriages and abortions. Strictly speaking, fetal mortality does not include the termination of life at very early stage of pregnancy, which might more accurately be termed embryonic mortality. This distinction is rarely necessary since demographic studies usually start only after 4 weeks of pregnancy, taking the first menstrual period as proof of conception. World Health Organization recommends that is to group all these as fetal deaths, distinguishing early, intermediate and late mortality according to the duration of pregnancy. Bongartz and Porter suggest that this figure of 20% of pregnancies ending in fetal deaths is a slightly overestimate. It arises because there is a chance that some of the apparent fetal deaths in the first few weeks, especially week 4 and 5, are simply unusually delayed but normal menstrual periods. You can see the figure number 1, Bongartz and Porter data of fetal mortality. Fetal mortality by time since last menstrual week. Here fetal mortality by percentages. it declines from 8.1 gradually up to 16 weeks of menstruation to 0.5 at 40 weeks of menstruation. This is the table which gives the fetal mortality by age and in weeks. Time since last menstruation is given, menses is given, and then fetal percentage mortality is given. Limitations of the SM. Number 1. The SMR on account of the low number has to be interpreted with attention to random variation effects. That is, care would be needed to be taken if few deaths would affect the interpretation, for which suitable statistical techniques can be used. Number 2. SMR also cannot be used for comparison across areas as the population profile differs and are weighted differently to age-specific death rates. Number 3. The data quality also matters such that if there is no linearity to changes in population or death rates, then accuracy is affected. Number 4. Additionally, there are also errors in the codes related to cause of death which cannot be easily ascertained, which could be in turns affect the accuracy of the results. B. Comparing across SMR is difficult across different populations of study as the relevant weights are the stratum size of the relevant population rather than of standard population. Therefore, it can only be compared if standardization variables such as age were to be distributed identically across the populations. A crude death rate could be directly compared. It would be unnecessary to have case standardization. Even if the directly standardized rates for populations of comparison were to be exactly the same, although already probabilistic as there is no precision to the rates for a particular strata, the indirectly standardized rates would differ. SMR can be compared across populations which differ in their age distribution in a certain situation wherein there is no variation by age or there is uniformity in the stratum specific rates for each of the populations, thereby making the age distribution not important. Regardless of the weight used, the average obtained from identical rates will always be the same if there is uniformity, otherwise a single average would not be suitable. Instead, directly comprising standardized rates may be a better option. An illustration is provided in the following article. Source: Scorbis, 1999, Standardization of Rates and Ratios, available at the following link. Thank you very much.